Good morning. In this video, I'm going to solve a question which was asked in the A-level examination of the winter 2020 paper number 41. So this question is on partition coefficient. So if you do not have the basic understanding of partition coefficient, you are advised to watch my another video on partition coefficient in which I have introduced the topic. So let's go forward and let's solve this particular question. Water and octane 1-ol form two layers when mixed. Ethanamide is more soluble in water than it is in octane 1-ol. When 1 gram of ethanamide is added to 50 centimeter cube of water and this is then shaken with 50 centimeter cube of octane 1-ol, it is found that the water layer contains 0.935 gram of ethanamide at equilibrium. Calculate the partition coefficient KPC for ethanamide in water and octane 1-ol. So here I have tried to show this in the form of a diagram. This is a separating funnel and you can see that we have two layers. One is the layer of water, 50 centimeter cube, and another is the layer of octane 1-ol because they are mutually immiscible. So we have 50 centimeter cube of octane 1-ol as is given in the question. 50 centimeter cube of octane 1-ol and 50 centimeter cube of water, and 1 gram of ethanamide was mixed with 50 centimeter cube of water. So see this is 1 gram of ethanamide which was mixed in 50 centimeter cube of water, and then 50 centimeter cube of octane 1-ol was added to it. I've shown it as a lower layer considering that it is denser than water, and then they are shaken so that some of the ethanamide from the water layer would go into the layer of octane 1-ol because ethanamide is miscible in both the liquids. So part of this 1 gram would go into this and an equilibrium would be established when the amount of ethanamide in the water layer and the octane 1-ol becomes constant, and that is when the equilibrium would be reached. And at equilibrium it was found that there was 0.935 gram of ethanamide in the water layer. So if in the water layer it was 0.935 gram, then in the organic layer it should be 1 minus 0.935, that is 0.065, because we had started with 1 gram. And 0.935 gram is still present in the water layer. So if you subtract it, you will get the amount of the ethanamide which is present in the organic layer. Now, in order to find out the partition coefficient, we need the concentration of ethanamide in the water layer and the concentration of ethanamide in the organic layer. And to find the concentration, you should be aware that the mass is to be converted into number of moles, right? And for doing that, we have to divide the mass by the MR of ethanamide, and then after getting the number of moles, we have to divide by the volume in dm cube, and that gives us the concentration. But in this particular question, you can see that it's a ratio. And being a ratio, we are going to divide by the molar mass in the numerator as well as in the denominator, such that the MR will get cancelled out because it's there in the numerator and denominator. Because it gets cancelled out, we don't need actually to divide by the MR. Similarly, we don't need to convert the volume into dm cube, because once again, because it's a ratio. So when we divide it by 1000 to convert into dm cube, we are dividing the numerator as well as the denominator. So once again, that 1000 gets cancelled. So to simplify that, we don't need to consider the MR and we don't need to convert the volume to dm³. So simply you can take the mass in the water layer. Now because they have written in water and octane 1 all, it means that water should be in the numerator. So this is the amount present in the water layer, and this is the amount present in the organic layer. And even this 50 is not required because 50 would be cancelled out, and simply take this ratio and it turns out to be 14.38, which can be rounded off to 14.4 to 3 significant figures, and so that's the value of the partition coefficient. Now let's go on to the next part of the question, and the next part of the question is that the 50 centimeter cube of the water containing 0.935 gram of ethanamide is then shaken with 100 centimeter cube of pure octane 1 all under the same conditions, and calculate the mass of ethanamide that is dissolved in the 100 centimeter cube of octane 1 all at equilibrium. So now to understand this in a better way, I've shown it to you in the form of a diagram. So this is 0.935 gram of ethanamide present in 50 centimeter cube of water, and then it is shaken with octane 1 all, which is 100 centimeter cube. Some of the ethanamide would go from the water to the octane 1 all organic layer, and let us suppose that the amount which goes is X. So the amount remaining in water now is 0.935 minus X, and the amount which goes into octane 1 all is X. So these are the amounts, but as I said that we need the concentrations, and already explained before that we have to divide by the same MR in the numerator and the denominator, and the volume should be converted into dm³, but because it's a ratio, the conversion factors get cancelled out, so no need to take that into consideration. But this partition coefficient is already known to be 14.4 from the previous calculation, and the system remains the same, the temperature remains the same, therefore the partition coefficient remains the same. So this is the partition coefficient, and now simply you have to solve it. It's a mathematical problem now, and I have shown you the steps, mathematical steps, in case you are weak in math. So I have shown you the steps, otherwise this is just a math problem. So 0.935 minus X divided by 50 divided by X by 100, so you can write this, and then if you further simplify it, it becomes 2 upon X is equal to 14.4, right? And then change the sides, it becomes 14.4X, and 0.935 minus X into 2, which further gets simplified in the way that I have shown in these two steps, and finally you get the equation 16.4x is equal to 1.870 and x is equal to 1.870 divided by 16.4, which turns out to be 0.114. So the amount of ethanamide which would now go into the organic layer has been found to be 0.114 gram. So that is the answer to the question. Hope you understood. Thank you very much.